targeted audience. So basically, DevOps engineer, cloud administrator, and cloud engineers and cloud architects. These people are targeted for the Kubernetes thing because these days, everywhere applications are being containerized. And whenever we are talking about containerization, so obviously we need to have an orchestration tool, right? So that is Kubernetes. That is the reason people who is already working on cloud environments, they should learn. And the people who is planning to do the certificate, whether it is CKA or CKAD, they should join this training, and even CKS, right? All the certificate or any one of them you are planning to, you should join this training sessions. Now, guys, the prerequisites for this course, you should aware of few tools. What are those tools? Basics of Linux. You should be able to create files because we will be creating YAML files again and again. And the secondary thing is the YAML, how to write YAML, that you should already know. If you don't know, no problem at all. While starting Kubernetes, where YAML files are important on day-to-day tasks and each and every object file. So I will be training you on that. If you need some training, we'll do that something. And basics of any cloud, majorly guys, we will be doing implementation things on AWS. You should have one AWS free tier account, but free tier account will work only with Docker things. Once Kubernetes is started, you should use T2 medium instances which are not free. And I believe if you are just practicing and after the practice you are deleting your instances, you'll be getting um, very small amount of bill, around 500. 500 is also more. I'm saying, within 500 rupees you'll be getting some amount during this training. If you are keep deleting resources on the time, it will hardly within, it should be hardly within 100 rupees. But if you are practicing a lot, then on an average we can take it 500. But important part here that you need to remember, if you are not deleting resources and you are spinning up heavy VMs, you'll be getting charged like hell. So be aware while working with the cloud, right? If you are thinking that why to go for cloud, I don't want to go for any cloud. I don't want to pay a single rupee to the cloud people. I'm having alternate that also there. In that alternative, free lab will be there. I'll provide you. You can practice, right? You can create a virtual machine by installing Oracle VirtualBox on your laptop. I will be helping you to set up the lab on your locals, right? Course objectives. Let's talk about course objectives. What all things we are going to cover, how things will be there. So, very first of all, we will be starting things with Docker because Docker is the base for Kubernetes, right? We'll be starting with Docker. We will be learning Docker, what exactly Docker is, how Docker works, Docker architecture, and we'll be comparing it virtualization versus containerization on-prem, how these things it got changed day to day, right? What the difference between them? That will be doing a little bit comparison. Docker internals, how Docker is creating the containers and what exactly UFS Union File System is, how it is being created and all. The containers basically, what UFS. Docker volumes to persist data while using Docker containers. Containers are ephemeral. You created a container, your container started generating the data, and after some time, you deleted that container. In this scenario, nothing can be recoverable. How to persist the data? That thing will be covered in Docker volume types. What exactly images are, how to create the Docker images, pre-build solutions, custom image creation, right? How to save your image in a form of file and file to image format, right? How to store it on container registry to share with your colleagues in the team, and how to create pods in Kubernetes. That is a different scenario. That will be there. And access application outside of the server and within the server. What are the methods that how front end and back end communicates internally? Container to container communication. Now my front end is ready. I want to make it accessible for my users. So how to do that, right? That is one important point that we will be looking into. And after that, resource allocation to the container. See, resource allocation, I think this is not a good word. Resource limitation is a good word. Okay. How to limit on containers so that they can access limited resources on the machine. What happens is, guys, containers are running on the instances. We can assume that EC2 instance, okay. My EC2 instance is having 2 GB RAM and 2 CPUs. Usually, whenever we are creating container, so containers will not be restricted or limited to any resource. They can consume 100% available resources on the host machine. In this scenario, if your containers are resource hungry, they can consume all the space, all the memory and CPU available on your VM or EC2 instance or whatever it is, right? Instance. So how to limit such things that we'll be looking here. Then finally, Docker Compose is there, right? What exactly Compose is, how to start multiple container as single go, right? So that is what Docker Compose is that we will be looking into it. And after that, a quick comparison between Docker Swarm and Kubernetes. What exactly Docker Swarm is and what exactly Kubernetes is, right? And when it comes to the Docker Swarm, it is having very less feature functionality as compared to the Kubernetes. Kubernetes is far better than Docker Swarm. That is the reason everywhere all the companies are adopting Kubernetes. See, why they are not going for Docker Swarm? Even it is simple and easy. Even sometimes one more scenario is there, people are not requiring more feature functionality, but still they are moving to the Kubernetes only. Any company who plans to use containers, they need an orchestration tool. Docker Swarm is one of them. But the cost effect, if you are able to maintain Kubernetes with the same price, then why you will be going with Docker Swarm, right? The first thing. Second thing is that every company, every project, uh, they need additional feature functionality. Might be in upcoming days. Today, they might be feeling that, okay, we need or we are having small requirement, but they are in industry, they will keep developing their application. Upcoming versions will be there, new feature functionality might be required, and again additional work will be there for them, migrate from Swarm to Kubernetes. The hectic task. That's the reason they are avoiding to use Swarm. Everywhere they are using Kubernetes. Both are open sources. Both are open source. It is lightweight to install and maintain Docker Swarm. But if you see here Kubernetes level, you can see you need to put some effort to manage this environment, Kubernetes thing, right? And Docker Swarm is having so many limitations. Kubernetes, you can say that no such kind of things, but multiple plugins, applications, and feature functionality available in Kubernetes. We will be diving this in very deep once Kubernetes topic is started. Just we are discussing, the course content. That's it. Now let's move to another slide. Kubernetes course objective. What we'll be doing is, let's close this one. I'm having a Word document which contains things in very detail for Docker as well. Let's Let me add one more advanced thing here. One more thing here. Containerization tool. Whenever it comes to the containerization tool, Docker is not alone in market. Docker is just for beginners. Okay, beginners and till application containerization. But these days in Kubernetes, um, you know, we are having Docker's alternative available, Containerd and Cryo. Cryo you will be seeing in most secure environments. Cryo is super good actually. And Containerd will be there. It is also secure. It's not like that. But the preference, it depends on the architect who that person is and why that they are choosing a container D or prior. Totally depends. Now, guys, one important part here is again, we are going through Docker, but as I'm saying that these two things are also important. What will happen to them? You no need to worry about. We will be learning Docker, where container creation, image creation, volumes, those things will be covered. But when we will be starting Kubernetes, so our Kubernetes, we will be choosing any one of them, Cryo or Container D. And again, you no need to worry about how container command looks different over there. That I will take care of it. I will be I will be teaching you how to deal with the container if those are created with cryo or container D. It's super easy. If all the concepts are clear with Docker, then very similar command to Docker it will be there. One more is there called Podman. Okay, we'll be discussing about this too. Okay, all these type of small containerization tools we'll be discussing, and majorly Docker is the goal. And I believe that cryo we are going to implement. Why I selected cryo for Kubernetes training, because uh, you guys will be seeing cryo in your environment. Previously, Kubernetes directly used to support Docker, but direct support to Docker is being dropped by Kubernetes because of their competitor available in market. This is an important part that will be covered. Now, what we'll be doing is, as discussed, you know, we'll be learning architecture installation of Docker on Ubuntu EC2 instances. You can install it on Red Hat as well if you are having VMs, right? Installation, configuration, and its architecture of Docker will be discussed here. See, version check, basic commands, command execution inside the container, how to log in inside the container, how to read the log of the container, right? How to install application inside the container, copy data from the container to host and host to container. That part will be covered here as discussed. Architecture, services. Services are nothing but it is the part of the composting and networking, container to container communication, how it is happening, how to make container accessible outside of the machine or your instance, how to disable communication within with the containers, right? So those things we will be covering it, and UFS again, and images, custom images, registries, how to pull the image, how to push image to registries. So two registries I'm going to discuss. First one is Docker Hub, and second one is the GitHub. How you can place your Docker images to GitHub. GitHub, the reason to choose GitHub over here is we are having, so many registries, Artifactory, JFrog Artifactory, we are having Harbor, many, you know. So GitHub is the registry. We can say that if you are learning to push images on a generic registry, method will be applied, similar method will be applied to another registries as well, whether it is GK, sorry, um, Google Container Registry, Elastic Container Registry, ECR, and Azure Container Registry, right? Yeah, anything you can use it. If you are comfortable with GitHub, you can make work things there as well. So that is the reason, importantly, I mentioned here GitHub, right? This image push pull, whatever it is, container creation, application deployment, Docker networking, type of Docker network, network types, storage types. We are having few type of storage, like, bind mount, volume mount, tempfs. What exactly it is, we will be diving it in very, very deep. Backing up and restoring container images and Docker application data. Application data, obviously, with persistent volume, image restore, like as I said, how you can convert your images to a file and file to image format again and then container. How this flow works, that will be covered here. Docker file, how to write Docker file to containerize the application. You know, some generic ideas, generic things we will be discussing because in market there are lots of type of application: Java, Node, Angular, no, Go, Python, Perl, something .NET. So some generic things we will be discussing over here so that you guys can adopt the things easily. Better understanding on Docker file that we are going to achieve. Along with MSB, multi-stage build will be covered to reduce the size of images. That part, that is something important. And Docker Compose, as we discussed, starting a multiple container in the single go, that we will be learning here. WordPress will be using with some, MySQL image, front end, back end, container to container communication, and front end to outside of the machine. That we'll be learning about. Now, guys, we'll be starting with the Kubernetes. Kubernetes is something, mostly theory. Theory is also very important. It's not like I'll just go crazily and start doing this command, that command. No. Uh, it is 95% practical lab in our trainings. And initial days till Docker, uh, a week at least. Initially, we will be doing this training for Docker 1 hour per day. But Kubernetes is a huge course. Okay. Why it is a huge? Because, I designed it like sometimes, this is a benefit for the people who is joining this training. Sometimes, you might be hearing that, okay, people might be talking about this jargon saying that I'm going to do CKA, I'm going to do CKS or CK, something, CKD, right? So they are, most of the institution, they are like, charging uh, money for separate certifications. But here we combine two certificates majorly, CKA and CKD. Even if you are planning for CKS, you need to go through the same content. Okay, so it's a mix up for all the certificate, but no security thing, no CKS will be discussed in this training. Only CKD, CKS, CKA part. So this is a mix up. Both certificates content are mixed into this one. So that makes very easy for you to understand the things, because similar things will be there on both the certificates. And if you will be seeing it on other side of this course, the practical we are going to implement, which will be related to day-to-day activity in your workplace. Okay. From my experience, I got few of the examples with me here that will help you to understand what type of containers is being deployed on your environment, what all things are being done on day to day, right? Those things will be here. Let's come back to the Kubernetes course content discussion. So most of the time we will be discussing a topic theoretical first, and then practical implementation will be there for the same thing. Now, we will be talking about Kubernetes, what exactly it is, how it came into the existence, and after that, we will be talking about its architecture, how it look like, and then worker node concept, what exactly is master node concept, what exactly is that, what all components we can find in each of the nodes, what is the use of them, what they are doing exactly, like Kube API server on your master node, Kube controller manager, right? Kube scheduler, some CNIs and CRIs. CNI is nothing but container network interface, which is Calico, VNet, Cilium. We will be going to use Cilium and core DNS, what it is doing, and etcd to store your cluster state, cluster data in it, right? Kubelet, kube proxy, and finally container runtime, which is CRI, that we will be talking about in deep, how to form the cluster. Generally, let me start one of the widest whiteboard. Generally, guys, you might hear these terms in market. People are talking about like, EKS. People are talking about Elastic Kubernetes services, then Azure Kubernetes services, right? And GK, Google Kubernetes Engine. They keep talking about these things. And one more new term you might be seeing, Kubernetes with CKA or any certificate Kubernetes experience, and they're asking about OpenShift. Right? OpenShift is created on top of Kubernetes only. It is a product of Kubernetes, we can say. If you are able to work with Kubernetes, you can work with OpenShift. Now, guys, these are the cloud Kubernetes. These all, AKS, EKS, and GKE. Whatever things that we are going to learn in this course, few of the objects, Kubernetes objects, I'm discussing here, like deployments, deployments, right? Secrets, config map, role, role binding, cluster role binding, and daemon sets, right? And many more things we are having. These are the few I'm discussing here. Everything will work similarly, same as on the thing that we are going to cover. We'll be working on any of this cloud, including OpenShift. Now, what type of environment that we will be going to create. Okay, what type of environment we are going to create. So basically, we will be discussing, what is that? On-prem. On-prem style, on-prem like environment we are going to implement, where we will be having one master and two worker nodes. Okay, one master and two worker nodes we will be having, where we will be forming our Kubernetes cluster. Why we are not going for this cloud Kubernetes? Two reasons, guys. Cloud Kubernetes will not be giving you access of master nodes. You will not be having access of master node at all. You will have only access of worker node. Means lack of accessibility of infrastructure. If you guys are going with this on-prem style environment, where we'll be having complete control of our nodes, our cluster, and each and every component running inside the cluster will have access. We will be responsible to manage each and everything. We will be installing container runtime interface. We will be installing a container network interface. It's kubectl, kubeadm, kubelet, right? Initializing the cluster, generating the token, joining additional nodes to the worker node. Those things will be here from the scratch that you will never ever be going to find out this on this cloud Kubernetes. These are the separate topic. Now, the difference, let's talk about the differences between them. That okay, I'm going to join this training. I'm like, happy that I will be learning full advanced content and course with you. But what will happen to this AKS or cloud Kubernetes basically, where you will be lacking only the two places that you will be lacking, I'm saying. So first of all, cluster management. First part, cluster management, like creation, uh, updation, deletion I'll not mention, and are back. Only cloud level with users. These are the places after completion of course, if you are planning to learn any one of this cloud, these are the places where you will be lacking. But the plus point, the plus point, while you are aware of each and every things in Kubernetes, do you think that it will be hard for you to adopt these three things: creation, updation, and cloud level RBAC means creating user in cloud and then map it to cluster. If you are already aware of your favorite cloud, you can do that easily by following the documentation. If still you guys require any help, I'm here. I'm going to help you. So guys, these are the important points that needs to be discussed here. Right now, guys, we will be going back to see the course content again. Now see here deployment of Kubernetes cluster using kind of KubeADM. KubeADM clusters we are going to create later on. You can or we go with the kind. Kind is again kind of mini cube. Okay, mini cube with limitations, so many limitations. Similarly, kind will be having again limitations. Is better go for KubeADM. One master, two worker node. After that, cluster is ready. That's fine. You know, everything is fine. Cluster is ready. After that, we will be discussing about pod object. What exactly pod is? How containers are being created inside the pod, right? Pod contains one container or multiple container. That is the thing. If it contains multiple container, so how to log in into them, how to read the log, right? How to copy file inside the container from container to host, that we will be talking about, right? After that, container to container communication while being inside the pod and pod to pod communication is so confusable terms. It is I'm understanding this. Few of you who is new with this terms, containerization and Kubernetes, but you no need to worry about it. Keep things in mind. Slowly we will be more moving from uh, basic to advanced topic, then things will be keep getting clear day to day. And after that, we will be learning application deployment using the pods, front end, back end, how they are communicating, right? Again, similar way, right? Resource limitation, CPU memory for the containers. What exactly is that type of pods? Basically, we are having different type of pod. Our normal pods, static pod, and init containers. Those will be discussed. You know, creation of pod will not be allowing you to achieve highly availability within the Kubernetes. You need to create a few of the objects that will be replicating your container on desired number of no desired number of pods, so that if one pod is getting failed, so another will be started serving the traffic or request. How you can achieve this? To achieve this, we are having few of the Kubernetes object going to help us. Replication controller, replica set, and then deployment. Initially, when Kubernetes was released, we were having replication controller to replicate our pods in our cluster. But slowly time passed and we faced some of the challenges. Then Kubernetes people, they released another type of object called replica set to resolve few of the issues that we were facing. So again, replication controller is on, and then replica set came with new feature functionality. After that, again, replica set was lacking somewhere, and then deployment came. So basically, deployment works with replica set in background to create the containers, right? To achieve highly availability and rolling updates. They both the things work together. If you are creating deployment, automatically replica set will be created in the background. How to perform a rolling update, what exactly these things are, how they are different from one to others, right? So when to use which one, that we are going to discuss. Rolling update, let's say I'm running one application today, and after some days or months or years, my company is planning to release another version of my application with additional feature and functionality. Then how deployment object gonna perform a rolling updates basically. If anything goes wrong, so how I can do rollback to the previous version of application. These things we can do through deployment only. Okay. HPA, horizontal pod auto scaling. My deployment is running. My deployment is running with let's say few of the replica. um, 10 number of pods are running, just we are assuming it. Somehow resource okay resources are not available, and I suddenly, traffic got spikes up. Lots of requests started hitting to my application. In this scenario, what will happen? We are assuming 10 pods are not able to serve the traffic. Then we'll have to increase number of pods. Then what we will do? You can log in into the cluster, right? You can log in into the cluster and add additional pods, okay, additional replicas of your application, so that request can be served easily. This is the manual thing, but manual will not work in your production environment. Something should be automatically happen. Then we will be having HPA. HPA gonna add or perform auto scaling on your cluster for deployments. If particular threshold is reaching, a particular CPU usage is hitting, then it is going to add more replicas on your deployment. Whenever you are creating HPA, you need to define maximum number of pods on HPA. We will be implementing this thing practically. You don't need to worry about that. Another object, daemon set. This is mainly for logging monitoring tools. How it is different with the deployment object, that we will be discussing. A few points, few hints I want to discuss here. Uh, you no need to define number of replicas. Daemon set is something which will be creating pods in each of available nodes on your cluster based on the deployment rule, right? Stateful set is one another type of object which is similar, or advanced version of the deployment. Deployments generally will not be allowing you to access to deployment will generally not be allowing you to reach it out to the specific pod. Let's say, assume that you want to install MySQL cluster inside Kubernetes, or HashiCorp Vault cluster inside Kubernetes. How will do cluster inside cluster things is happening over here. Then this stateful set thing gonna help you. It comes up with feature. Um, you can make accessible your application within the cluster using cluster IP or headless service. It's a very detailed thing. We will be discussing this one as well. And one more advanced feature, stateful set is having volume claim template. Okay, you can define the template for volume claim PVCs. So based on that template, whatever whatever defined number of replicas are there, so each pod will be getting one volume created and attached it to the pod. Volume claim template is not supported or not available in deployment. Okay, this is the thing. We'll be discussing this one as well. Practically, see, the course is super huge. From I think half an hour, we are discussing more than half an hour, I guess. We are discussing about this. Still, discussions is going on. So see guys here, volumes, persist the volume data. What type of volume we are having? Ephemeral volume, temporary volume, persistent storage. What is the difference between ephemeral and persistent storage? That will be talking about different type of volumes like empty directory and host path. What is the use of these type of volume? When to use which one? How volumes are getting provisioned in my cluster? That and again, when it comes to provisioning the volume, there are two types of volume provisioning: static provisioning and then dynamic provisioning. What exactly static provisioning is? Static provisioning, where you will be going and creating volumes on your cloud and then mapping it to the Kubernetes, and then create your PVCs. But here's dynamic volume provisioning. You will be having some of the storage class installed within the cluster that will be going to the cloud to provision the volume dynamically and attaching it to your cluster, right? This is what exactly this volume provisionings are. PVC, storage class. That what we are going to discuss in the training session. Now, services. What is this services thing? Services are nothing but to make your application accessible internally or externally. Means within the cluster, front end wants to talk to back end, pod to pod communication. That will be happen through cluster IP. To make it accessible your application outside of the cluster, we are having node port and the load balancer. Node port, it is having two things involved in it, node IP and the port number. This is what exactly it is, node IP and port number, combination of two things. And the load balancer can be provisioned only on the cloud, but still on premises we are having solution to provision load balancer. We need to install and configure third party plugin that will be making it easy. So when to use which service, that again we will be discussing. Secrets, wow. Config map, storing your keys, your tokens, your passwords, your certificates will be done using secret. What is the use? Why to use? What exactly feature it is? What type of encryption method it contains? You know, we'll discuss. Secrets can be, uh, uh, you know, used in environment variables, in form of environment variables, as well as volumes. Both type of implementation we are going to do. Config map. What exactly config map is? Config map will be helping us to keep configurations in a centralized place so that we can call them in multiple deployment. Right. Now, now config map also can be used in environment variable as well as in form of file. This is the implementation that we will be doing. The secrets, ingress controller. Wow. Now, guys, just we seen that accessing our application outside of the cluster, we are already having node port and the load balancer. Then again, we got this ingress thing here. Right? Why we got this ingress thing? See, load balancer going to spin up one load balancer with IP address. You need to share that IP address with your users. Node port will be having IP plus port numbers, port ranges. Who will be remembering these IP and ports? You think expect of this one, your user. Do you think that your users will be remembering IP address? Even if you're joining a team, initially also it is very hard for you to remember these IP addresses. Then what? We can remember domain names, google.com, Facebook, visualpath.in, right? We can remember it. So that is the reason ingress controller comes into the picture to make your application accessible with domain names. We are having many type of ingress controllers available in market, but we will be using or we will be learning the most used or demanding one, which is Nginx ingress controller. How to make your application accessible with the domain names like anish.com or something visualpath.in, right? So how to do this one, that we will be implementing it practically. We will be creating virtual domains and we will be accessing our application with the domain names. Even you can do path-based routing, right? Sometimes path-based routing means google.com/shop, google.com/blog, like this, how to route a request based on the path. This is what we are going to implement, guys, ingress controller. Now, scheduling and health check. Let me complete this health check first. How to make sure that your containers are healthy? We are having two type of health check, liveness and readiness, that we will be discussing. And when to use which one, what is the feature that readiness is having, what is the feature of liveness is having. If you look into liveness will be checking the health of container. If container's health is not good, it will be killing the container and creating a fresh one, where readiness probe will not be killing it, but readiness will be stopping traffic towards landing on your container, basically. Okay, until unless state of container is not healthy, it will be avoiding to have request on your container. But liveness will allow the request. Okay, even container is getting filled, request will be keep landing to the container. So that is the reason we should use both together for the containers. We will be learning this one. Now, guys, scheduling needs to be discussed. Different type of scheduling we are having. Let's say I want to deploy my pod on a node based on the node name. Then again, another type of scheduling mechanism is node selector. Based on the node label, I want to send my pod in particular type of nodes. Pod affinity. Pod affinity is something, one pod is running in node 1. And what I'm thinking that, okay, my pod should go wherever a pod is running. Means assume that my pod name is Mango, and Mango pod is running somewhere in my cluster, some random nodes. I don't know the node name even. But what my requirement is, I'm creating one more pod called Apple. This should go and get deployed in a node wherever Mango pod is running. Then this pod affinity comes into the picture. It will find, okay, in which node this Mango pod is running. It will be placing Apple pod there as well, right? Anti-affinity. Do not go in a node where Mango pod is running, go somewhere else. This is what will be achieving here. Node affinity. Based on the node name, node label, sorry, my mistake. Based on the node label, our pod will be getting placed in it. And anti-affinity, our pod will not be going and getting deployed in a node wherever a pod, sorry, wherever a node label is something. Okay, we will be diving it in very detailed way on scheduling. Taint and toleration. Taint is applied on the node and tolerations will be applied on the pod. Special kind of labels with effect. Because of the taint only your pods are not going, application pod I'm talking about, okay? Because of the taint only your pods, application pods are not going and getting deployed on master node. It is stopping it, okay? So that is what we will be looking into this in very detailed way by implementing each and everything. Finally, guys, you know, finally we are end of the course content now. RBAC. RBAC is something role-based control, access, authentication, authorization, how it happens in Kubernetes. We are having a team. Assume that we are having a team. Every person is having their own roles and responsibility based on the job role. How you will be assigning access to the one second, how you will be assigning your users to access based on their job role, that we will be learning here. Cluster wide access you want to give, or access to a particular namespaces. Now again, what is namespaces? That also we will be discussing about things in very detail. Role binding, cluster role binding, how it works, how to bind users and service accounts to a role and cluster role. That part, guys, we will be diving here. And cluster upgradation, how it happens, that is interesting part that will be there. And finally, we will be completing the Kubernetes course, but still it is not ended actually. Still this is not done. What I feel is we will be learning about Helm chart. Uh, Helm chart is there. So I will be teaching you how to Helmify your YAML files, writing the Helm chart, installing application, perform rolling upgrade, and uninstall application using Helm chart, how to create our own chart, right? How to convert existing YAMLs to the package means chart and place that chart into chart repository, and then do the installation from your own chart from the chart repository. And yeah, this we will be completing it. Helm chart will be in quite, you can say that, in detailed way. We'll be learning Helm chart in detail, but rest of these three things, introduction part is there, how to install Argo CD, log like ELK stack and Prometheus Grafana and access the data. Do the deployment using Argo CD. This is that we will be looking into. And when it comes to Logstash and Kibana, Prometheus, Grafana in very, very detail, that we will not be doing that. It's already huge course. I don't want to make it super huge. So that's the reason we will be not doing deep dive on these three things, just installation and the important thing that you will be dealing in your day-to-day, accessing the log, that part we will be looking into. So that's all, guys, about course introduction part. If you guys are having any question queries regarding this course content, please ask me. Now, okay, let me add one more thing. Q&A will do after 2 minutes or 1 minute. Guys, the important part here is, let's say you are joining the course. Okay, so what all things you will be getting apart from training? We will be providing you dumps based on your requirements, CKA or CKA AD, right? Whichever you need, we will be providing you dumps very first. Second thing is that recordings will be given to you. As discussed, 1 hour for Docker and 1.5 hour for 1.5 hour per day for Kubernetes we will be doing. And after this training hour, let's say you guys are practicing and you started facing some difficulties, then how you will be resolving it. You no need to worry about that. We will be creating WhatsApp group. You guys will be added over there on that particular WhatsApp group. While facing any difficulty, you can keep posting your question queries on WhatsApp. I'll reply over there. Sometimes if I'm in a meeting or traveling or somewhere, so delay, expect a delay, right? Now, certificates, you know, offers. Certificates are costly basically. CKA certification if you do here. So it cost CKA and CKAD, both certificates, guys, will cost you 395 USD. Oh my goodness. No, it's for bundle price. Che. Exam only, they increased price. My goodness. Surprise. 445. No man. Here we'll go and check. Price. See, 395 USD. They increased the price. What the hell is this? So these guys are keep increasing the price. Previously it was 295 USD, then it is 395 USD, now it is 445 USD. Exam only price. They increase the price. They are making lots of money basically. So this much of money you'll have to pay if you want to do instant certificate, you want to get something, right? You can do that. If you are thinking that I want to get a discount, so you need to wait for American holidays, Christmas, New Year, some Black Friday, something. So those deals you need to wait for it. It will be reduced till 50% off, sometimes 30%, sometimes 45%. It depends, right? So if you are near about Christmas or New Year, then you will be getting 50% off, sometimes 60% off. So it totally depends. Once you purchase this voucher, so what will happen, you will be eligible to appear in this exam within 12 months. Okay, within 12 months you can go for the examination, and certificate validity is for 2 years. Duration of exam is 2 hours. Mode of exam is online. You can do this from your home as well. And one very important thing, while going for this examination, you should have a room where should be there, and nothing should be on your desk, including you know your cell phone, headphones, microphones, another laptop, and they will be keep checking each and everything. Your complete room will be inspected by a proctor. They will be checking like what all things you are having under the desk, your chair, your arms. No hand watches are allowed. Where so many restrictions it is having. If you are failing in this exam, one retake will be there. It will be giving you one of the PDF certificate digital badge will be given to you for showcase on your LinkedIn profile or somewhere. Software version 1.31. This is performance based exam, not MCQ. Multi choice will not be there. There will be the scenario, and you will have to implement those things on live clusters. Exam simulator will be given to you guys. What exactly exam simulator is? A dummy exam. Before going for a real exam, exam simulator can be used twice. Okay. If you are passing in this exam simulator, then 100% you can pass real exam. Okay. And this is something important about the examination. If you need anything, help on examination, I will be there. Not in exam, but yeah, I can help you a lot.